base number. So my base number is 2. And I'm multiplying it by itself 2 times. So this is the same as 2 times 2. But then I'm multiplying it by 2 to the power of 3. So then how many times am I multiplying it more times? 3 more times. So it's 2 times 2 times 2 times 2 times 2. Okay, so I have 2 to the power of 2 times 2 to the power of 3. We're just doing 2 times 2 times 2 times 2 times 2 times 2. What do you get when you do that? And this is something that you can quickly do on your hand, right? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. What is our final answer? 32, good. 32. So any questions on this first one? Very, very important that we understand how to do the basics. That way when we get to the harder stuff, it makes more sense. So please, any questions at all, ask them now. Cool. All right, moving on to the second one underneath. I have a fraction here, but I still have a base number and an exponent. So I'm still doing the same kind of thing, except for here, I'm doing 2 times 2 times 2 over 2 times 2. So what do I get in the numerator? What's 2 times 2 times 2? 2 to the power of 3.
8.
We got 8 in the numerator. And then 2 times 2 in the denominator?
4.
4. And what is 8 divided by 4?
2.
We end up with 2. Any questions on that one underneath?
Oh, I only put the fraction. I didn't know we had to like simplify it more.
Oh, okay, so you left it as 8 over 4. Well, just remember that anytime in this class, anytime you have any fraction, you always have to make sure that you simplify it at the end. Now, technically 8 over 4 isn't wrong, but it's if the question says to simplify, it would mark it wrong. So you just have to make sure you're always putting things in the simplest terms. All right, the third one. I see parentheses, I see multiplication inside those parentheses, and then there's also an exponent. If I'm following PEMDAS, what should I do first?
Parentheses.
Good, we're gonna do those parentheses first. So 2 times 3
6.
is 6, so this is 6 squared, which would be 6 times 6. 6 times 6?
36.
36. So that's number 3. Any questions on that one? Awesome. Okay, now number 4 is a little bit trickier because I have a fraction and I'm taking it, the whole fraction is being taken to the second power. But remember, what does a fraction tell you to, or what does an exponent tell you to do again?
Multiply by the same number.
Right, so if I'm taking it to the power of 2, I'm just multiplying the base number times itself. Well, my base number is a fraction. So what I'm doing is 2 over 3 times itself, times 2 over 3. So I have a fraction times a fraction. Now, who can remind me, when I have 2 fractions and I'm multiplying them, how do I do that? What do I do to those numbers? Be more specific, Guillermo. I know I'm doing math. Good, Juan. We're going to just multiply straight across. Numerator times the numerator, denominator times the denominator. So 2 times 2, I get 4. 3 times 3, I get 9. 4 over 9. That's that. Any questions on this one, number 4? Cool. All right. And then the last one I have an exponent and then another exponent. So it's like double exponent. Well, in this case, again, I have parentheses and I have an exponent. Which one do I do first?
The parentheses in the inside.
On the inside, yeah. So 2 to the power of 3, that's 2 times 2 times 2. 2 times 2 times 2, as Allison just said, that's going to be 8. 8 to the power of 2,
64.
64. 64. All right. That is kind of the basics. How do we feel? Any questions on the basics before I make your life more difficult? All right, cool. Now, again, I'm going to just stress this. We are all starting fresh. Today is a brand new topic. So those of you who maybe weren't doing so well on linear functions, that is in your past now. Today is the chance to move on, to start something new. So just make sure you take that opportunity to participate a little bit more. Make sure when I assign homework next week, because I'm not assigning homework tonight, but I will next week, you're doing it and making sure you keep track of all of those things. Set alarms on your phone, keep a calendar, keep a planner. Just figure out ways to organize yourself so that you're not forgetting to do your assignments. That's going to be super important. Now, I do have an announcement. Actually, I have two announcements. Today, I don't know if your sixth period teachers have told you yet, but today the district is doing their walkthroughs and they will be coming into the virtual classrooms during sixth period. So whatever class you have that period, make sure that you're doing your best to, your cameras have to be on. You have to be wearing your uniforms. So if you don't have them on right now, make sure you put them on later. And, ooh, my voice. Okay. And just make sure you're participating and, making your teachers look good today. We do our best to help you guys out. So return the favor today when you see those district people come into your Zoom. So that's one announcement. The other announcement is that I am actually going to be absent for 3 days. So I'm going to be out tomorrow, Monday, and Tuesday. I'm okay. I have a couple of things that I have to get done. So I will be back next Wednesday. However, I'm still assigning work and you have to do the work. I have a few people in this class who think that teacher absence days are free time. You can do whatever you want. Absolutely not. You got to do your work. And most importantly, it's going to be an easy A. So if you don't do it, you're missing out on the chance of getting a nice, easy A in the gradebook. I'm not going to make it very difficult, but I do expect every single person to complete their work because if you're not in class, you have to be doing something, okay? So I'm not going to overwhelm you guys, but I do expect everybody to be completing their work. And if you do not, I will be making parent phone calls because I'm still around. I'm just not going to be available during the day. Understood? Can I get just a verbal thumbs up confirmation that everybody here agrees that they will do their assignments that I put up while I'm absent?
Yes.
Okay.
Yes.
Thank you guys. All righty. Perfect. So with that all being said, let's go ahead and get started. So I'm going to write down a couple of pretty easy exponent problems. I just want you guys to look at them and then fill in the blanks on your sheet of paper, write them down, and fill in the blanks of any of the values that you know the answer to. I'm going to start off pretty easy. Okay. So which ones does anyone want to fill in some blanks here? You can do the annotation tool. Three to the power of 1, 3 to the power of 2. Go ahead and fill it in. What about 3 to the power of 1? Okay, I see a 3. Okay. All right, so some of these are correct, some of these are not. So let's go ahead and look at them. So 3 to the power of 1 is 3. So that one's good. That's correct. 3 to the power of 2, that's 9. That is correct. 3 to the power of 3. 3 times 3 is 9. 9 times 3 is 27. That is also correct. Now the rest of them, you all got fooled. Y'all thought you were right, but in fact, these are wrong. So let's go ahead and figure out what they actually would be. So there's a pattern going on here, okay? Let's take a look at what we have so far. I'm gonna figure out the pattern, and then I'm gonna work backwards to figure out what the other ones are gonna be. So let me just organize. All right. How do I get from 3 to 9? What do I multiply by? Times 3, right? Okay. From 9 to 27, what do I multiply by? Also times 3, right? Okay, so the pattern is that going forwards, I'm going to be multiplying times 3. Well, now if I want to figure out what comes before, if I'm moving backwards, I should divide by 3, right? Because that's the opposite. So if I go the other way, I need to divide that value by 3. Well, what is 3 divided by 3? 1. 3 divided by 3 is actually 1. So 3 to the power of 0 is 1. And I know that looks a little weird, but let's continue. Let's keep going and see what happens. Who keeps putting in these wrong answers? Wrong answers. It's okay though. We're learning. Okay, let's do it again. Now I'm dividing by 3 again. What is 1 divided by 3?
1.
1 divided by 3. Think of it like a fraction. 1 divided by 3 is the same as 1 over 3, 1/3. And in fact, if you put it into your calculator and you try to do 1 divided by 3, you're going to get 0.33333, which is just the decimal version of the fraction, which is 1/3. So whoever put that in, that is correct. It is going to be 1/3. Do it one more time now. Good job, Juan. 1/3 divided by 3. Let me do that over here. 1/3 divided by 3. This is keep, change, flip. Y'all remember keep, change, flip? Who remembers keep, change, flip?
Class.
Yeah, it's been a while, but let's review it really quickly. If I'm dividing by 3, 3 as a fraction is 3 over 1, right? 3 over 1. So 1/3 divided by 3 over 1, keep, change, flip, what do I write?
You have to flip it. You have to flip the fraction to multiplication.
Good. So I keep the 1/3, I change to multiply, and I flip my fraction. 1/3 times 1/3, I multiply straight across, because it's two fractions, I'm multiplying straight across. 1 times 1 is 1. 3 times 3, 9. I get 1 over 9, 1/9. Now, who was it? Juan wrote it down correctly. I'm just going to rewrite it as a fraction so that we can clearly see the pattern, because it's a little hard when it's using text. So there's the pattern. So kind of weird, right? These exponent rules. Things get a little weird whenever you have exponents that are not whole numbers. But there is a pattern that it's following. So I want you guys now, I'm gonna I'm going to just move this up. Let me actually do a couple of things. Hold on. We're going to do it again, but with different numbers now. Hold on. Okay. All right, so let me move this up. Here we go. And let me rewrite the values I had over here. This was 3, this was 9, that was 27. Now I want you guys to do the same exact thing, but this time I'm going to use the number 5 as my base number. So 5 to the power of negative 2, 5 to the power of negative 1, 5 to the power of 0, 5 to the power of 1, 5 to the power of 2, and 5 to the power of 3. All right, go ahead and fill anything in that you know you got right. Ooh. Make sure if you're trying to annotate it, there's a button. Can anybody actually explain where the annotate button is? Because I'm not sure what it looks like on your screens.
So the annotate button, you'll see like a green tab on top of your screen that says you are viewing Miss Lopez's screen, and then there'll be this tab called that it says view options. You click that tab, and then you scroll down until you see exit full screen, and then under exit full screen you'll see annotate, and then you click that, and then voila, you have the magic of the Apple Pen.
There you go. And on mobile, it's a little different, right, Juan? Okay. So I'm seeing that some people are correcting each other. I see, let's see. Things look okay. I'm not sure what's going on the left side. What's going on over there? 5 to the power of negative 2. Is it 1 over 10? Is it 1 over 25? What is it? Okay, 1 over 25. I think we've agreed on that. And what about all the way to the right? 5 to the power of 3. $125. Beautiful. Okay, good job, guys. I'm gonna I'm gonna make this look a little bit neater, but it looks like everybody got it all correct. Good job. So I'm just gonna rewrite things a little bit more neatly. Okay. So 5 to the power of 0. Anything to the power of 0 is 1. Then I have 1 over 5. Then I have 1 over 25. And then the other way, 5 to the power of 1 is 5. Then 5 to the power of 2 is 25. And 5 to the power of 3 is 125. Do I have any question? Anybody wondering how in the world I got these numbers? Because I am happy to do it one more time as long as we are able to understand it. Okay, a couple people who were here a little bit late. So that's why it's important to be here on time, y'all. You missed out on some important info. So these 3 that I have in green are the ones that we all pretty much we know how to do, right? We just 5 to the power of 1 is itself, that's just 5. 5 to the power of 2 is 5 times 5. 5 times 5 is 25. 5 to the power of 3, 5 times 5 times 5 is 125. So the pattern going in this direction is that we're multiplying by 5 times 5. So we could just go forwards. Then in the opposite direction, to follow the pattern, since I'm going backwards, now I got to divide by 5. Right, so I got to do 5 divided by 5. 5 divided by 5 is 1. So 5 to the power of 0 is 1. If I keep that pattern going, I'm dividing by 5. 1 divided by 5 is 1/5. Okay, 1 over 5, 1 divided by 5. If I continue the pattern one more time, I got to divide by 5 one more time. And here's where I have fractions. So let me do this. Let me just move this up a little bit so that I can fit it. Okay. So I'm doing 1/5 divided by 5. Well, 1/5 divided by 5, I need to do keep, change, flip because I have a fraction. Keep, change, flip, I keep the 1/5. I change division to multiplication. And I flip my 5. 5 over 1, when I flip it, is 1 over 5. Then I multiply. 1 times 1 is 1. 5 times 5 is 25. I'm getting a phone call, y'all. I have to take it. Give me 5 minutes or tops. I'll be right back.
Okay.
All right, I'm back. That wasn't too long. No partying, Guillermo. I'm sorry. Anyways, what are we confused about? Because I see some confusion in the chat.
Oh no, I'm
Why-
saying I'm confused about what everyone's talking about.
So who's confused about this one's always the most confusing, the power of 0. Who's still confused about that one?
Wait, but Miss Lopez question. What will happen if we have to force say it's 5 over 2? I mean
5 to the power of 2?
yes, 5 to the power of 2 and 25, and then it will tell us to go all the way to 5 over 0. Will we have to like divide it by 25 then, or still by 5?
Well, at that point, Ijara, the pattern is nice when you're going from one to the other, nice and slowly. But we're going to actually be writing down the rules in just a moment, which you're always going to follow. So you don't need to know the pattern as long as you memorize the rules. When you know the rules, you can just know the answer off the top of your head.
Oh, okay.
Now, 5 to the power of 0 is confusing. I understand that. It is. This is definitely the one that most people have issues with. Remember that exponents aren't telling you to multiply by that number, right? If I have 5 squared, I'm not doing 5 times 2. What am I doing? Five squared is what? 5. It's 5 times 5 times 5, right? So the power, that number, that exponent is not telling you to multiply by that number. It's just telling you how many times to multiply by itself. So if I have 5 to the power of 0, this is not telling me to do 5 times 0. That's not what it's telling me to do. Okay? So don't get that confused. What it's telling me to do is it's saying take 5 and multiply it by itself 0 times. But that's where it's kind of weird, right? You can't really do that. So it is a weird rule. I completely agree that it is weird, but think about why it makes sense using the pattern, okay? The pattern is that you're dividing by 5, right? So here, 5 to the power of 1 is 5. Do we understand that? This is telling me multiply 5 by itself, when I do 5 to the power of 1, it's telling me just leave it alone. Leave it as 5. 5 to anything to the power of 1 is just itself. Going backwards, 5 to the power of 0, I have to divide by 5. Well, 5 divided by 5 is 1. So since 5 is the base number, when you divide it by itself, it's 1. 5 divided by 5 is 1. So that's why we end up with the answer of 1. The same thing happens with our 3's. same thing. 3 to the power of 1 is itself, it's just 3. Going backwards, 3 to the power of 0, I have to divide. 3 divided by 3 is 1. So every single number, no matter what number, if you take it to the power of 0, you get 1. Any number in the world. 1,000 to the power of 0 is 1. How's that? Any more questions on that idea?
Now I understand. So if we divide and then we go back to the negatives, it's
Mhm.
just the thing. It's just the same thing as a positive, but instead it has a 1 over it.
Yes, yes, exactly. So that's a very good thing to notice, Ajay. Let's look at this one. Look at 3 squared compared to 3 to the negative 2 power. So 3 to the power of 2 is 9. 3 to the power of negative 2 is 1 over 9. And look at the same thing happens over here. 5 squared is 25. 5 to the power of negative 2 is 1 over 25. So it's the same number. I still have a 25. It's just that when it's a negative exponent, it goes to the denominator.
Now I understand. So that means we don't have to do that much.
Right, you don't have to follow the pattern every single time. And in fact, in the next screen, I'm going to have you guys write down the 2 rules that we just kind of learned about. So to the power of 0, you run the number through a duplicator, separate them, and then slap a division symbol in the middle. Okay, I get it now. If that makes you remember it, Juan, you do you. All right, so here are 2 exponent rules that we're starting off with. We are going to be writing quite a lot of them today. There's 8 in total. So start by writing these 2 and then leave some space wherever you're writing them. Leave like a good amount of space because there are going to be 8 in total. So just make sure that you don't run out of room. So I'm going to give you guys about 3 minutes to start off with this. 3 minutes. Yes, write both of them. Both of these rules. All right, let me know in the chat how many more minutes you would need if you need more time. 1 minute? Okay. Keep working, keep writing. This is true. Juan and Najira are 100% correct. All right, about 20 seconds remaining. Alrighty. Now, if you didn't finish writing, I do have it on the next slide. So it's there. All right. So with these rules now, like I said, you no longer need to be following that pattern because now we have rules we can use. So let's go through these examples. I want you guys to write these down in your notebook. You are writing today. Lots of writing because there's a lot of rules today that you will need to go back and refer to. So please make sure you're writing these notes. So let's start off with the first one, 10 to the power of negative 2. So we're following this pattern right here. Let me circle it. 10 to the power of negative 2 is the same as 1 over 10 to the power of positive 2. I'm just following the pattern. Okay? And then and then 10 squared, like Ajara, you're completely right. 10 squared, 10 times 10 is 100. So 10 to the power of negative 2 is 1/100th, 1 over 100. Questions on number 1? Good. Number 2, 56 to the power of negative 1. It's a negative exponent, so I know it's going to turn into a fraction. That's going to be 1 over 56 to the power of positive 1. And 56 to the power of positive 1 is just 56. That's my answer. Pausing there, questions so far? Okay, moving right along. 2 to the power of negative 4. 2 to the power of negative 4. I'm going to turn it into a fraction. It's going to be 1 over 2 to the power of positive 4. Now be careful with 2 to the power of positive 4. We're not doing 2 times 4. We're doing 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. Questions on that so far? 1 over 16. Okay. Now the next one gets a little bit interesting. I have a fraction to the power of negative 2. But let me go off to the side for a second. I'm just going to look at our first example one more time. Just revisiting number 1. How do I write the number 10 as a fraction?
10 over 1.
10 over 1, right? So I'm just going to rewrite this for a second. 10 over 1, I kind of just rewrote it as a fraction, became 1 over 10, didn't it? Does anybody know what that is called when you have a fraction and then you flip it? Anybody know?
Same as KCF.
So it's the same idea. It's the same thing you do in keep, change, flip, but it actually has a name, a vocabulary word. Starts with an R. Okay, so I'm going to go ahead and write it down. That key word is the reciprocal. You might have heard it. Reciprocal. Reciprocal is when you flip a fraction. So that's what happened in number 1, number 2, and number 3, right? We started with a whole number. Well, that whole number can be written over 1 as a fraction. And when you do a negative exponent, we flipped it, we have the reciprocal. So the same thing happens in number 4. So take a look at number 4. What is the reciprocal of 1 over 3?
3 over 1. 3 over
3.
1.
Good. 3 over 1. 3 over 1. So I take the reciprocal. My exponent now is positive, and 3 over 1 is the same as 3. So this is 3 squared, which is 9. So let's kind of just bring it all together. A whole number, like in example 1, example 2, and example 3, a whole number to a negative exponent goes in the denominator. So it becomes 1 over that number. A fraction to a negative exponent becomes a whole number. Notice that? The whole numbers became fractions, and then our fraction became a whole number. So whichever number you start off with, it's going to flip. Everything that was in the numerator goes down to the denominator. Anything that was in the denominator goes up to the numerator. And that is what negative exponents do. That's what they're for. How were we feeling? Any questions, any confusions? Okay. Number 5, negative 2 to the power of 0. What's that? Good one. That's 1. Any number to the power of 0, that's the easiest one. Any number in the world to the power of 0 is just 1. Just 1. So don't get fooled by those. It looks tricky, but it's actually super, super easy. Any number to the power of 0 is 1. Okay, gonna move this over. Now, here's this last one. For the last one, I have multiplication and I have an exponent. Following PEMDAS, what do I have to do first?
Exponents.
Exponent goes first, right? So I have to do 6 to the power of negative 2. What is 6 to the power of negative 2 going to become?
1 over 36.
1 over, good. 1 over 6 to the power of positive 2, which is 36. So I have 3 times 1 over 36, which will just be 3 over 36. Can I simplify that? Good, Juan. That's 1 over 12. So that one was a little bit trickier just because you had to do 2 operations. But remember, anytime you have more than 1 operation, you're going to follow PEMDAS, always. How do we feel? Questions, comments, confusions, concerns? Okay. So these are only the first 2 rules. Remember, we have 8 in total. So I'm going to continue on, but I'm going to make sure that tomorrow, when I am absent, as well as Monday and Tuesday, we're just going to be doing a lot of practice on this because I want you guys to make sure that you master all of the basics. And then, after I come back, we'll really move on to the more difficult problems. So I'm revisiting these problems from our bell ringer. We actually did these already. But the reason I'm revisiting them is because I want to talk about some patterns that happen when you are using exponents and using different operations. So in the first example, now you can write these again, but more importantly, I just want you to watch and notice the patterns that I'm going to point out. In the first one, what are we doing between the two base numbers? What operation is happening here?
Multiplication.
Good, it's multiplication. I have multiplication and my base numbers are the same. I have 2's. Both of them are 2's. So I have multiplication with the same base number. Well, we actually got an answer already, right? We know that this is the same as 2 times 2, that's 2 squared, and then 2 times 2 times 2, 2 to the power of 3. So how many 2's are there in total?
5.
5, right? So I can rewrite this as 2 to the power of 5. I'm actually going to leave it like that because now I want us to think about what patterns we see. What happened to the exponents that I started off with? The 2 and the 3 became a 5.
Added.
We added the exponents. So when you're multiplying numbers that have the same base, so I had a 2 to the power of 2 and a 2 to the power of 3, you can just add the exponents. And like I said, you don't need to write this down yet because we will be writing the rules in just a moment. But that is essentially going to be our first rule that we're going to talk about. Here's the second one. We know that this one was 2 times 2 times 2 over 2 times 2. Now what happens in here in this one? What was our final answer? I believe I had 8 over 4. So we end up good. So we end up with 2. Now another way to think about this, by the way, is that 2 of those 2's cancel out since one is in the numerator and the other one's in the denominator. So we just end up with 2. Now technically this is 2 to the power of 1, right? Because anytime you just have a number on its own, it's the power of 1. So, okay, so now let's see what happened. Originally, what operation were we doing here?
Division.
Divide.
Division, right? I had division with the same base numbers. And then I had a 3 and I had a 2. And that became a 1. So this time we're not adding the exponents. What are we doing?
Dividing.
Well, I had a 3 and a 2.
Oh, subtracting.
Subtracting the exponents. Okay, so notice the pattern. When you multiply the base numbers, you add the exponents. When you divide those base numbers, you subtract the exponents. Okay, now let's take a look what we had in number 3. Number 3 is a little bit different, right? Because I had multiplication first, and then I had to do the exponent. So this was the same as 6 to the power of 2, which gave me 36 in total. But I'm going to write this a different way. I want you to see what I can also do. I can also write this as 2 squared times 3 squared. 2 squared is 4. 3 squared is 9. 4 times 9, 36. I came about the same answer a different way than when we did it the first time around. what happened in this example is that what did I do with that exponent?
Multiplied it?
Kind of. It's a little bit like, what is this?
Duplicate.
Duplicate, there's another word.
Distribute.
Distribute, that's the word I'm
Oh.
looking for. Distribute, yeah. So we had multiplication. Did we have the same base number?
No.
Not the same base number, but we had multiplication in the parentheses. And what we did was we distribute the exponent. So far I have, in the first one we added the exponent, in the second one we subtracted the exponents, in the third one I was able to distribute the exponent because of those parentheses. Well, the same thing kind of happens in the fourth example. In the fourth example, I have not multiplication. What do I have here? It's a fraction, but a fraction is really, a fraction is what type of operation? So I'm doing 2 over 3, that's the same as
Division.
Division.
division, right? So again, this time I have division in the parentheses. What I can also do here is distribute my exponent. So now I'm going to have 2 squared over 3 squared. 2 squared is 4. 3 squared is 9. So same thing, distribute the exponent. Okay, questions up to here? So far, these patterns sort of, they're a little more intuitive. That's why I did the first two, the really confusing rules first. These rules are a little bit easier to remember. Now, this last one, when we did it, we had to do 2 to the power of 3. Two to the power of 3, 2 times 2 times 2. And then we had to take that to the second power. Well, this is the same as 2 times 2 times 2 times 2 times 2 times 2. Right? When you take something to the second power, you're simply multiplying it by itself. Well, how many 2's do I now have?
6.
6, right? 2 to the power of 6. So what was happening in the original? I had a power to a power. It was like double exponent, right? I had a power, and then I was taking that power to another power. What happened between these two numbers, 3 and 2, became 6. What operation do I do between the 3 and the 2? Multiply. Good, Juan. We multiply the exponents. Running out of room. But that covers 7 out of 8 of the rules that you guys are going to be learning today. So one more time, let me go through them all one more time. In number 1, we were multiplying the base numbers, so we added the exponents. Number 2, we were dividing the base numbers, so we subtract the exponents. So think about that. When you multiply, you add. When you divide, you subtract. Then in number 3 and number 4, we were able to distribute the exponent into those parentheses. And then in the final one, when you had a power to a power, so we had 2 to the power of 3 to the power of 2, you multiply the exponents. Questions on the patterns before I have you guys write down the actual rules? All right, so here we go. There are a lot of them. Take your time. You already wrote number 1 and number 2 if you were here. So you do not need to rewrite those. However, go ahead and continue writing the remaining rules. I will start off with 5 minutes on the timer, and then we'll see if you guys need a little bit more time after that. I have 1 minute remaining on the timer. Let me know if you need more time than that. Alrighty, that is time. Anybody still need a couple seconds? Awesome. Alrighty. So now that we have these rules down, I'm going to go ahead and start looking at some practice problems. Because like I said, we started off with the basics, we're going to move on and it's going to get a little bit harder each time. However, those rules are going to be the most important thing to keep in your notebook. You can always refer back to them until you've memorized them. And once you memorize them, it's going to be really easy. So starting with number 1. Sorry, I didn't label these, but let me label them now. 1, 2, 3, 4, 5, and 6. All right. Starting with number 1, which rule that we just wrote down, which of those rules does number 1 correspond to?
Rule number 3.
Rule number 3, the product property. The product property, if I'm multiplying the same base numbers, what do I do to those exponents?
Add them.
We're adding the exponents. So 11 plus negative 8
Like Juan said, it's 3.
is 3. So I have 4 to the power of 3. All I had to do was add up those exponents. Questions on number 1? All right, number 2, which rule does that correspond to? Number 4, good one. Quotient property. This time, I'm not going to add the exponents. I am going to subtract the exponents. So I have -6 minus -5. And when you subtract, make sure you're doing it in the right order. It's going to be the one from the numerator minus the one from the denominator. So top minus bottom. Now, this one's a little bit trickier. -6 minus -5. What happens when you got a double negative like this?
It turns into a positive. Well, no.
It's a plus sign, right? Yeah. I have a plus. So I have -6 plus 5, which is what?
-1.
-1. So I've got 6 to the power of -1. Now, how can I rewrite that 6 to the power of -1?
1/6.
1/6. Remember, negative exponents will turn, you're going to get your reciprocal. So that 6 becomes 1/6. 1/6. Technically, this is 1/6 to the power of +1, but we can just write it as 1/6. Questions on number 2? That one was a little bit more involved. Okay. Number three. Okay, now I don't have any numbers. In fact, 3, 4, 5, and 6, I just have variables, but we're still following those same rules. So in number 3, am I adding, subtracting, or something else? Good job, Juan.
Adding.
Yeah, we're adding. You got it. Adding the exponents. So I have 2 plus -12. In other words, 2 minus 12. 2 minus 12 is, I see Juan's got it in there, -10.
10.
Right? Let me just keep the, okay, -10. So I have x to the power of -10. How can I rewrite this one?
1/x/10.
1/x to the power of +10. Exactly. Okay, Now, number four, adding or subtracting.
Quotient.
It's the quotient rule, so I am going to subtract the exponents. So am I doing 7 minus negative 14, or am I doing negative 14 minus 7?
Negative 14 minus 7.
Other way. Remember, top minus bottom.
Oh, yes. 7.
Top. 7 minus negative 14. So again, I have a double negative, so this becomes 7 plus 14. 7 plus 14?
21.
21.
21. So I have z to the power of 21. Okay, and that one I can leave because I don't have any negatives. So number 5 and number 6, I want you guys to try it on your own. I'm going to give you guys about a minute. Try to do it as quick math as you can. I'll give you guys a minute and then we'll go over it together. 1 minute on the timer starts now. Okay. That was 1 minute. I'm gonna give you guys about 30 seconds because I know a couple people are still typing. All right. Okay, number 5. Number 5, I'm going to be adding those exponents. So I have negative 6 and 11. That's negative 6 plus 11. What's negative 6 plus 11?
5.
It's 5, positive 5. So my final answer is going to be b to the power of 5. Questions on number 5? Awesome. Okay, now number 6, I'm subtracting. Am I going to do 6 minus 8 or 8 minus 6?
6 minus 8.
6 minus 8. Top minus bottom. 6 minus 8, what's that?
Negative 2.
Negative 2. Negative 2. So I get x to the power of negative 2. How do I rewrite that? I have a negative exponent. So what do I end up with?
1x to the power of negative 2.
Good. 1 over x to the power of positive 2. All right, so those are all all of those problems? How do we feel? Any remaining questions, any remaining confusions? If there's one in particular that anyone would like me to do again, I'm happy to do that now. The most important thing though is to make sure that you are writing these down, because like I said, I'm not going to be here tomorrow. I'm not going to be here on Monday or Tuesday. So when you have to do this on your own, which when I assign a little bit of work for you to do, making sure you have this in your notebook is going to make you can look back on it and see what we did today. Okay, I'm getting a request to do number 3 one more time. Okay, so let's look at number 3. In number 3, I was adding the exponents. Now I'm adding them. However, one of those exponents is negative, right? So I'm doing 2 plus negative 12. 2 plus negative 12. You can think of that as 2 minus 12. 2 minus 12 is a negative 10. So it goes both ways, right? You can either do 2 plus negative 12, or just simply think about it as subtraction, which is 2 minus 12. So we ended up with x to the power of negative 10. And since that's a negative, I know I have to make that into a fraction. So that became 1 over x to the power of 10. Okay. All right. Now let's move along. Here's a couple more. We're going to kick it up a notch, just a little bit. There's a lot more kind of going on in these, right? But we're still going to follow those rules. Still going to follow those same rules. Starting with, let me label these, number 1, 2, 3, 4, and 5. Okay. So with number 1, let me go back to the rules really quickly. Can anybody identify, so think about these rules, which rule does number 1 seem to need, which one are we going to need to use?
Rule number 1. Oh, no, wait, hold on. I'm sorry. I thought you were talking about like rule number 1.
Okay, in problem number 1, which rule that you guys wrote down do I need to use?
Rule number 5.
Rule number 5. Let me look at it one more time. I have power of a power. That's true. So I am going to need to use number 5, and there's one more I'm going to have to use.
Really? Can we go back to the... The extra rule is for the other ones, right?
Nope, still for problem number 1.
Really?
Let me rewrite it one way, see if it helps. I'm just rewriting this. I have 4b. 4b, that's 4 times b. So there's multiplication going on.
Oh, and also rule number 3.
Close, not number 3.
6?
6, yeah. 5 and 6. So I have power of a power and I have power of a product. So let's go back and take a look. So what's going to happen is this exponent on the outside, what do I do with it? How do I apply it to the inside numbers?
Oh, distribution.
Yeah, we're going to distribute it to the 4 and distribute it to b to the power of negative 3. Well, when I do that, I get 4 to the power of negative 2. And then what do I do with the negative 2 and the negative 3?
You add.
Not add, be careful, but multiply. Because let's go back to those rules. Rule number 5, sorry. Rule number 5, power of a power. If you've got a power on the inside of the parentheses and then a power on the outside of the parentheses, we multiply. Okay, so we are multiplying. What is -2 times -3?
B over -6.
Six.
Negative times a negative is a
Oh, it's a positive.
Positive.
+6. +6. So I have 4 to the power of -2 times b to the power of -6. I didn't give myself quite enough room here, so I'm just going to keep going over here. 4 to the power of -2. How can I rewrite that?
1 over 4 by the positive power of 2.
Good. And what is 4 squared?
1 over 8.
Careful, 4 times 4 is
16.
16. So 1 over 16 times b to the power of 6. And now my last step is I'm just going to kind of mush these together. I can just bring this b to the numerator. So b to the power of 6 over 16. And that's my answer. So there are we're just going to be taking more and more steps in our each of these problems. So questions on number 1. And I think this is the last page we're going to do today.
Why did you add B6?
Why did I put it in the numerator?
Mm-hmm.
So I didn't show this step, but what I really did, remember, any whole number, how do you turn any number in the world, any whole number, into a fraction? So like the number 10, how do I turn that into a
Divide.
fraction?
Division.
Put it over what?
1.
Over 1, right? So all I did was I put this over 1 and multiplied across. I didn't show that step because we're getting to the point now, guys, where these little kind of minor details, we can skip them over because we know basically all I did was I just moved him up to the numerator. The numerator is where all the whole numbers are. The denominator is where all the fractional numbers are. So since b is a whole number, he can live up top in the numerator.
I was going to say that if there's like a 1 in a fraction, well, there will be a 1 in a fraction. And if you have this sort of situation, you just add that 1 wherever it is.
Yeah, in the numerator. Yeah. All right, so that was number 1. Now what I'm going to do is, since I have a lot written down here, I'm actually just going to, if anyone is still copying, just going to move that over. Uh-oh, I don't have enough space. Well, I'm going to put the final answer here. Okay. Number 2. Number 2, very similar. I'm going to have to use both of those properties. I have a power, an exponent on the outside. I'm going to have to distribute it into my parentheses. So I have 3 to the power of -4 times a. Now what do I do? 5 and -4, I'm multiplying. So good, Juan. We get a to the power of -20. Questions at this point? Now I rewrite things. What happens to that 3? I have a negative exponent. So what do I turn it into?
A fraction.
Fraction, good. So 3 is now 1/3 to the power of 4. And what about a?
A will be a over by the power of -20 over 1.
So That won't be my final answer though, because the power of negative 20, since it's a negative exponent, what do I do now?
Oh, 1 over a by the positive power of 20.
Good. Good, good, good. Okay. Now, what is 3 to the power of 4? 3 times 3 is 9, times 3 is 27, times 3, 27 times 3,
80.
81.
81. So I have 1 over 81 times 1 over a to the power of 20. Final step is I'm just going to multiply these together. I just multiply straight across. 1 times 1 is 1. 81 times a is just 81a to the power of 20. Now, as we continue on, it's basically going to be the same sort of steps. First thing, we distribute that exponent that's on the outside. Then we deal with those new exponents. If they have negatives, I got to turn those into fractions. If you're able to evaluate an exponent, so like I had 3 to the power of 4, I can actually do that math. So you do that math, and then you always want to combine everything at the end. How do we feel? Questions up to here?
For the ending, you couldn't like multiply it because of the variable, so you just put them together.
Yeah. That's just me. They're still being multiplied. 81 and a to the power of 20, they're just being multiplied. But remember, when you have a number next to a variable, we already know that that's multiplication. 81a is just 81 times a. All right. Number 3. Okay, we got a couple extra things going on inside, but we're still going to distribute that exponent to each and every number or variable. Okay, oh, it gets, no matter how many things are in there, it gets distributed. So I have 3 to the power of 4. Then I have s. What's that going to be? S to the power of? Good, 12. We multiply. 4 times 3 is 12. And then I have k to the power of what? Good, negative 12. Okay, because I had 4 times negative 3. Now let's simplify a little bit. 3 to the power of 4. We kind of just did that. What's that going to be?
80.
81. So I have 81 times s to the power of 12 times k to the power of negative 12. Which of those values is going to end up in the denominator?
The
The k. The k, we know it's got a negative exponent, so I know that that's going to live in the denominator, but the rest of them, the 81 and the s, they're good. They're good to go. They're positive. They're whole numbers. They're not going to be in the denominator. So when I'm going to skip a few steps, I'm doing them in my head, but I'm skipping them on paper. I have 81s to the power of 12 over k to the power of 12.
K to the power 12 went at the bottom because it was supposed to be a fraction either way, right?
Exactly. Okay, Now, based on that, I want you guys to try number 4 and number 5. Those two are much more like number 3. So I'm leaving number 3 up. That way you guys can refer to it. And I'm going to put 3 minutes on the timer. Go ahead and try number 4, try number 5. Even if you're stuck and confused and you're not really sure what you're doing, do your best, try something. And even if it's wrong, we can do it. When we do it together, you'll learn from your mistakes. Juan says, can't you remove the powers of 12? You cannot. The only time where you can do that, Juan, is if you have the same base. But since I have an S and then I have a K, those don't match, right? So you can't just get rid of them because that would not make any sense. They have to match. One minute left. All right, that is time, and we are running out of time for class, so I definitely want to just move through these, get them done, and then we'll be out of here. So, number 4, I start by distributing that exponent. I get 5 to the power of 2. W to the power of what?
8.
8, good. 4 times 2 is 8. And then B to the power of
4.
4. 2 times 2 is 4. Does anything end up in the denominator?
No.
No, we got all positive exponents, so that's good. Now I just need to evaluate whatever I can. I know I can do 5 to the power of 2. 5 to the power of 2 is
25.
5. So I have 25 W to the power of 8, B to the power of 4. Nothing in the denominator on this one.
So you don't add the exponents together?
No, because remember, you only add the exponents if they have the same base. So if I had
Okay.
B to the power of 8 and B to the power of 4, then yes, this would be B to the power of 12. But in this case, I have a B and I have a W, can't combine them. All right, last one. Here we go. I get 2 to the power of 2. b to the power of 10, and c to the power of
4.
1.
multiplying.
Oh, it's 4. Yeah.
-4.
Yeah, -4. Do any of these end up in the denominator?
Yes.
Which one?
C.
C does. All right. So before I do that, let me just evaluate. 2 to the power of, 2 to the power of 2
4.
is 4. And my c is going to go into the denominator. So I've got 4b to the power of 10 over c to the power of 4.
Oh, I forgot to evaluate. I forgot to like evaluate.
Okay. All right. So that is that. You guys kind of got a glimpse. Basically, what I'm going to be assigning you all tomorrow is a Khan Academy review, a video to watch, and then some problems to do on your own. This is why I'm saying it's super important to make sure you wrote this down. I will also be posting this recording onto YouTube tonight so that tomorrow, if you need to watch it again, you can do so. Alrighty, so that is all for today. Keep an eye on Teams tomorrow morning so that you can see the assignment that I posted. And yeah, guys, I won't see you for a little while. So have a nice weekend. Have a nice start to next week, and I will be back on Wednesday. All right.
All right. Stay safe.
Bye, guys. Thank you. Bye, everybody.